Hello and welcome to another exam paper walkthrough. We're continuing with our series looking at the GCSE Maths June 24 papers, and this is aiming for a preparation paper for the 2F. This is based on very likely topics as produced from First Class Math. He's produced an excellent key topics revision list, and this paper is based around that. I would strongly recommend you download a copy of this paper first and do it either before or alongside the video. In the description to this video there is a copy of the paper, a link to the copy of the paper. So I would recommend you do that beforehand. I would also recommend having some music on in the background. I tend to record the videos with an ear pod in, so I have some music on in the background, just helps a little bit. If you find this useful, please do subscribe if you like. So this is a copy of the paper, just basic instructions, same as the usual exam paper. This paper is quite a big paper, it's out of 132, and like I said, it's based around the very likely topics. This paper is produced from First Class Maths key paper 2 topic list, so that he produced a really great useful student-friendly revision list. I've written this paper based on highly or very likely questions, and I've also done a second video and second paper based around good chances. You can see where they fall in that. There's no guarantee that these topics will come up. It's just a forecast based on an analysis of past series and questions that appeared on paper 1. I don't actually think there are in this paper, but there may be a few overlaps. That's just because it's an overlap in skills. Once I had this revision list, I went ahead and produced from using Pearson's Foundation Enhanced Skills Mapping Grid. I selected all the questions that I wanted. Then I arranged them by mean percentage, so starting easy and then gradually getting more progressively hard. So it should build nicely. And this is an outline. It's not, it doesn't fit exactly. Actually, this one does fit exactly because there's no overlap. So this is kind of question 1, question 2, and so on, if you find that useful. Right. Question 1. Here is part of a train timetable. Graham gets to the station in Brighton at 7:15. How many more minutes does he have to wait until the 7:22? So this is fairly straightforward. In effect, we're doing 07:22 minus 07:15, which would give us 0 hours and 7:07 minutes, so 7 minutes. Work out how long it will take the 7:22 train to get to London. So the 7:22 train to get to London, so again 0900 minus 07:22. Obviously kind of in my head, it's going to take 38 minutes to get to 8, so it's going to be 1 hour and 38 minutes. If you're not particularly confident with that, you can use your calculator in time mode if you're confident with time mode, so it's a good opportunity for me to show you the time mode. Right, if I can just edit my paper slightly, bring my calculator in without getting rid of too much. Right, so on your calculator mode, we've got this, I'll actually make this really large so you can actually see. You've got this time function, this is actually the time function on your calculator. So we can type this in as 09 hours and 00 minutes. And from that we want to subtract, we don't need the 0 really, 7 hours and 22 minutes. And then it will automatically work it out 1 hour and 38 minutes. That's the seconds, but we don't deal with seconds. So how long will it take? I'm going to go 1 hour and 38 minutes. Right. Let's just make my calculator a bit smaller again. There we go. Question 2. Here are the first 5 terms of a sequence. Write down the next 2 terms in the sequence. We want to look at the differences. So the difference there is 2, difference there is 3, difference there is 4, difference there is 5. The next difference must be 6, so we're looking at 21. And then the next difference there must be 7, so we're looking at 28. Question 3. Here is a list of numbers. From the list of numbers, write down a square number. So the square number is going to be 25. From the list, write down a number which is both a multiple of 4 and a multiple of 5. So multiple of 4 and 5, we're looking at 4 times 5, 24. Write down all the prime numbers in the list. So if we get rid of the even numbers first of all, and then multiples of 3, and then multiples of 5, and then we're only left with 23 and 29. I can check that they're prime numbers by using the factor button on our calculator. So for example, if I'd have gone 25, I go alpha fact, but I've pressed the wrong thing there. Shift fact. It says that's 5 squared, so it breaks down into its prime factors. So 23 shift fact, sorry, 25 shift fact 23. So that tells us its prime number. We could do the same for 29. Right, question 4. A baker has 3 bags of flour, A, B, and C. Bag A and bag B contain the same amount of flour, and bag C contains 940 grams of flour. In the 3 bags, there is a total of 250 grams of flour. Work out the amount of flour in bag A. So if I just extract this information, just to make it a bit easier for myself. So bag A and B contain the same amount, so I'm going to call that X for now. And bag C contains 940. And then the sum of that is 2,500. So in effect, 2x plus 940 must be equal to 250. That's right, 2,500. So if I do 2,500, first step is to minus 940 from both sides. So I'd get 2x is equal to 1,560. Divide both sides by 2, x is going to be equal to 780. Just double check that we've answered the amount of bag in flour A, so 780 grams. Question 5. Emily drives 186 miles in 3 hours. What is her average speed? Well, speed is equal to distance divided by time. So that's going to be equal to 186 divided by 3. So 62 miles per hour. Sarah drives at an average speed of 58 for 4 hours. How many miles does she drive? Well, if speed is equal to distance divided by time, distance is equal to speed times time. So 58 times by 4. 232. Question 6, solve. If I simplify that, that would be 3x is equal to 51. Divide both sides by 3, x is going to be equal to 51 divided by 3, 17. For the next one, I'm going to times both sides by 4, so y would be equal to 12. And finally, solve this one. So we're going to start by minusing 7 from both sides, so 2f is equal to 11, then divide both sides by 2. So x is equal to 10.5 or 10.5. And in Russian, 11 divided by 2 is not 10.5. Hopefully you spotted that. It's 5.5. Okay, question 7. Work out 20% of 80. So I would just do 0.2. That's 20% as a decimal times by 80. So 0.2 times by 80 gives me 16. Question 8, simplify. So we can only simplify the number part here. So 3 times by 5 is 15, FG or GF. Simplify t times t, that would become t squared. Common misconception is it is not equal to 2t. T times t is equal, that would be t plus t. T times t would be t squared. And then finally, simplify. In effect, we can kind of view it that we're going to take 2 out as a common factor of the top line, and then divide that by 2. So that would be n plus 3. Question 9. Here is a 4-sided spinner. The table shows the probability that when the spinner is spun, it will land on a 1, 3, or a 4. The spinner is spun once. Work out the probability that the spinner lands on a 2. Well, these probabilities would need to add up to 1. So it's going to be 1 minus 0.3, 0.6, 0.7, 0.7, so 0.3. Which number is the spinner least likely to land on? So that's the one with the lowest probability, so that would be a 4. And Jake is going to spin the spinner 100 times. Jake is going to spin the spinner 60 times. Work out an estimate for the number of times it will land on a 1. So we're going to go 60 times by 0.1, which would be 6. Question 10. This table shows the length of 5 rivers. Write down the rivers in order of length. So starting with the shortest. So the shortest length here is going to be the Don. The next shortest is going to be the Mercia, or the Mersey. Next smallest from this list then is Trent. We've then got between these two, the shortest is Thames. Put an E in that I didn't need. And then finally we've got 7. Emil says the river Thames is more than 3 times as long as the river Don. Show that Ami is correct. So if I take the river Don, 112 times by 3, it's going to be 336. And then 336 is less than 346. Question 11, write as a decimal, so that's going to be 0.017. And we can do it as division. Question 12. Here is part of a bus table from Bury to Manchester. How many minutes should the 8:25 bus take to get from Burnley to Manchester? So 8:25 Burnley to Manchester. So I'm going to use that time function again. 0, 9. I'm going to type it in, show that I'm using the time function, minus 0, 8 hours and 25 minutes. Because it can be quite useful when it comes up. 0, 5 minus minutes minus 0, 8. And it doesn't matter the 0. I'm just sticking to 24 hour. So 40 minutes. Daniel goes from Whitefield to Manchester by bus. Daniel takes 17 minutes to get from his house to the stop in Whitefield. He takes 15 minutes to get from the bus stop in Manchester to work. Daniel has got to be at work by 10 AM. He leaves home at 8:45. Does he arrive by 10 AM? So let's look at his journey. So we're going to go 10 hours plus the 17 minutes it takes for him to get to work to the bus stop. So that's where I'm going to start with. So he can catch, so I'm going to start there. So that means that he can catch, so he gets to the bus stop at 10:17, and let's see what bus he would catch. So we're talking about, so 10:17 means that he will catch the last bus. So no, he won't. So I've misread completely. So he leaves his house at 8:45. I thought that was quite a late time to get on the bus. Right. So I should have done right at the start. Oh no, I didn't type it in on my calculator. So he's going to get to the bus stop at 9 hours and 2 minutes. So the bus that he can catch is going to be this one. So he can catch the 9:04 bus. So 9:04 bus, and that's going to get to Manchester at 0. So that's going to get to Manchester at 9:35, and then to that we need to add this 15 minutes. So I'm just going to do 9:35 plus 15. 0:15 is going to be 9:50. So does he get to work on time? Yes, he would. Just checking my figures. Yes, he would be 10 minutes early, or he would arrive at 9:50 AM. Same format as the question. Right, question 13. Kobe has to find the perimeter of this rectangle. He has done 7 times 5. What mistake has he made? He's worked out the area. The area, not the perimeter. So here is the triangle. Aram solves a problem about the triangle to find the value of x. His answer is -2. Explain why this answer must be wrong. So we can't have a negative length. We can't have a negative length for x. Question 14, work out 1/6 of. So I'm going to do 1/6 times by 66. So that's the same as 66 divided by 6, so 11. Question 15, 200 people live in a village. 23 of them do not have a garden. 10 males do not have a garden. 95 of the people are male. Use this information to complete the frequency tree diagram. So we've already got 200 put in. 23 do not have a garden. So we've got 23. 10 males do not have a garden, so we're going to go 10 in that box there. And then 95 people are male, so I'm going to put a link there, say 95. So that's kind of my first level. That's information from the question. I'm now going to work out other parts. So that must be 13. That must be 85. This value must be 200 take away 23, so that's going to be 177. And then this final value here, 177 minus 85, gives us the value of 92. One of the people who does not have a garden is chosen at random. So does not have a garden, that means my denominator is 23. Write down the probability that the person is female, so 13. 13 out of 23. Question 16, here are 4 fractions. Write the fractions in order of size, starting with the smallest. So on a calculator paper, I would convert all of these to decimals. So that's going to be 0.75. 5 divided by 7 is going to be 0.714 dot dot dot. 19 over 25 is going to be 0.76. And then 11 out of 15 is going to be 0.73 reoccurring. So from there we can put them in order. The smallest fraction we've got is 5 over 7. The next smallest is 11 over 15, followed by 3 over 4, followed by 19 over 25. Question 17, Margaret is thinking of a number. She says, my number is odd, it is a factor of 36 and a multiple of 3. There are 2 possible numbers that Margaret is thinking of. Write down the 2 numbers. So I'm going to start by looking at 36. So I've got 1 and factor pairs of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Okay, so I'm after odd numbers that are multiples of 3. So we've got an odd number there that's a multiple of 3. We've got a multiple of 3, but that's not odd. We've got an odd number there. And that's the only 2 odd numbers that are multiples of 3. So 3 and 9. And question 18, simplify. So we add the powers for the first one, so that's m to the 7. The second one, we cube each part, so that would be 5 cubed, 125, n cubed, and then we multiply the powers here, so p to the power 9. And this bit, we're going to split it into 3 parts. 32 divided by 2 is going to be 8. P to the 9 divided by p to the 3 would be q to the 9 divided by q to the 3 would be q to the 6. And then r to the power 3. Question 19. Rotate the shape 90 degrees clockwise about the center. So nothing wrong with using tracing paper, but I will tend to go, I'll look at this position. So that's 2 across and 1 down. So it goes 2 across, 2 to the right and 1 down. So it's going to go 2 up and 1 across. So that point would go to there. So I've got the same shape drawn from there really. So following it around. That's my shape. Describe fully the single transformation that maps B onto C. So that's it's a mirror image, so it's a reflection in the line x equals 0, or you can say the y-axis. Both of those are fine. Question 20. There are 84 calories in 100 grams of banana, 87 calories in 100 grams of yogurt. Prita has 60 grams of banana and 150 grams of yogurt for breakfast. Work out the total number of calories in this breakfast. So we want to do, so if we kind of view it as a fraction, 60 out of 100 times by 84, that'll give us the number of grams in the banana. And then likewise 150 divided by 100 times by the 87. I want to add them together. So I'm going to just tidy up slightly as I go. So 6 over 10 times by 84 plus 51.5 times 87. So we've got a total of 118.5 calories. 181.5 calories. And I've just spotted that I typed this in slightly wrong, didn't I? Should have been 84 there, not an 85. So that's right. So we're looking at 180.9 calories. Question 21, change into millimeters, so we're dividing by 10. So that's going to be 3.5. Milliliters into liters, so we're dividing by 1,000. Oh, I've gone the wrong way. Over here, I've gone the wrong way. No, I haven't. So divide by 1,000, 7.7. There's the multiply one. So kilograms to grams, we're timesing by 1,000. So that would be 320. Okay, question 22. Ken buys some fruit. He buys bananas, apples, and peaches and oranges. Ken buys, and we're given some information. Each orange has a weight of 90 grams. The fruit has a total weight of 1.785 kilograms. Work out how many oranges Ken buys. So we're doing 4 times by 125 plus 3 times by 170 plus 3 times by 135. So that gives the total of the weight that we've got so far. So 4 times 125 plus 3 times 170 plus 3 times 135 gives us a total weight so far of 1,415 grams. That in kilograms is 1,785 grams. So the weight of orange is, we're going to do 1,785 minus our answer, and then we're going to divide that by 90. So and I can type it in like that if I want to. 1785 minus my last answer divided by 90 gives me an answer that does not make sense. So let's just quickly scan for errors. Right, might be that I typed something wrong here. 4 times 125 plus, there we go, it was 2, not 3. 2 times 170 plus 3 times 125, 1245. So 1785 minus my last answer, and then divide that by 90. So 6. Jane wants to buy 15 tomatoes. She asks for 1 kilogram of tomatoes in a shop. Jane assumes that each tomato has a weight of 75 grams. If Jane's assumption is correct, will she get 15 tomatoes? So let's just do 75 times by 15. So 75 times by 15 is going to be equal to 1,125. So no, as I will convert that. 1.125 kilograms is greater than 1 kilogram. If Jane's assumption is not correct, could she get 15 tomatoes? Justify your answer. I'm going to say yes if tomatoes weigh less than. So 1 divided by 15 gives us 60 grams, 66 grams. So yes, if tomatoes weigh less than 66 and a sixth of a gram, 66.6 recurring grams. Question 23. Table shows information about the number of points scored by 30 students in a quiz. Find the modal number of points. So the modal is determined by the greatest frequency, which would be 7, and that would be 2. So the modal point score is 2. Work out the total number of points scored, so we're timesing these and adding them together. So we don't need to do 0 times 4. 1 times 3 plus 2 times 7 plus 3 times 5 plus 4 times 6 plus 5 times 5. So that's 81. '24. Annie and Lynn share some money in the ratio of 4 to 3. What fraction of the money does Lynn get? So we've got A to L. We've got a total of 7 parts. So Lily gets 3/7 of the money. Rosie and Dan share some sweets. Dan gets 1/4 of the sweets. Write down the ratio of the number of sweets Rosie gets to the number of sweets that Dan gets. So Rosie first, then Dan. So that's going to be 3 to 1 because we've got 4 parts. So in effect, like I did before, we've got Rosie and Dan. And we know that there are 4 parts because of the denominator, and we know that Dan gets 1. So there are 3 parts left. Question 25. There are 495 coins in a bottle. 1/3 of the coins are pound coins. 124 of the coins are 50 pence. The rest of the coins are 20 pences. Work out the total value of the 495 coins. So we've got £1 coins, we've got 50 pences, and we've got 20 pences. So before we do it as a number, let's do 1/3 of this number. So 1/3 times by 495 is going to be equal to 495 divided by 3. So we've got 165 pound coins, we've got 124 50 pences, and then this is our missing value. So these would add up to make 289. Let's just double check that. Plus 124. Right. So we want to do 495 minus 289. So 495 minus my last answer gives me 206 50 pences. And reading the question, it doesn't actually ask us for the number of 50 pence. That's why it's always best to read the question. So what it actually asked was the value. So to work out the value, I'm going to do 165 plus 0.5 times by 124 plus 0.2 times by 206. So 165 plus 0.5 times by 124 plus 0.2 times by 206. And that gives us 268.2 pence. 268.2. Question 26. 4/5 of a number is 32. Find the number. So, if x times by 4/5 is equal to 32, then in effect we need to say that x is going to be equal to 32 divided by that. So 32 divided by 4/5. 32 divided by 4/5 gives us 40. So the original number is 40. Okay, 27. Write the following fractions in order of size, starting with the smallest. So we had a similar question to this earlier. I would do it the same way. So I'd write them all as decimals, convert them to decimals, fairly standard on a calculator. So 0.625, 2/3, 0.6 reoccurring, 4/9, 4 divided by 9 equals SD, 0.4 reoccurring, and then 2/5 is the same as 0.6. So in order of size, the smallest one there is 4/9. A couple of people get these two confused, saying that they're the same size. This is 6 reoccurring, so it's actually bigger than 0.6. So 3/5. We've then got, so we've got rid of that one and that one. We've then got 2/3, and then finally 5/8. Right, separate them with commas. Final step. Question 28. The table shows a cricket club's income in 2016 from a fete, a quiz, and membership fees. Expressed as a ratio, the income from the fete to the income from the quiz to the income from the membership fees. Given your answer as a ratio in its simplest form. So we've got F to Q to membership. Right, so straight away we're told that that's 250. The quiz, entry fee and refreshment, so 13 at 5 and 35. So I'll do that as a sum actually. 13 times 5 plus 35. So that gives us a total of 13 times by 5 plus 35, 100. And then the membership fee is 25 at 20. So 25 times by 20 is going to be 25 times by 20 is going to be 500. So in effect, we've got 25, 250 to 100 to 500. All of them are going to have 25s in common. That will go 10 times into that one, 4 times into that one. Actually, all of them have got 50 in common, so let's go by that instead. 250 divided by 50 is going to be 5. 100 divided by 50 would be 2. And then 500 divided by 50 would be 10. We're looking at 5 to 2 to 10. Question 29. Daniel bakes 450 cookies. He bakes only vanilla cakes, banana cakes. Why did I say cookies? 450 cakes. He bakes only vanilla cakes, banana cakes, lemon cakes, and chocolate cakes. 2/7 of the cakes are vanilla. 35% of the cakes are banana. The ratio of the number of lemon cake to the number of chocolate cakes is 4 to 5. Okay, let's work out some of the numbers then. So we've got vanilla cakes are going to be equal to 420 times by 2/7. So we've got 420 times by 2/7 is going to be 120 vanilla cakes. Chocolate cakes, sorry, banana cakes next. So banana cakes are going to be equal to 35% of the number. So we're doing 420 times by 35%, so times by 0.35. So let's just delete that fraction and put 0.35. So we've got 147 banana cakes. The rest we're splitting in a ratio, so we need to work out how many we're splitting in the ratio. So currently that adds up to 267. And if we've got 420 cakes in total, oh, I could have done this a different way. We'll stick with this method though. So the number of lemon to chocolate is currently 4 to 5, and we're splitting 420 minus 267. So we're splitting 420 minus the answer. So we're splitting 273 in that ratio. So divided by 9. So divide by 9 equal. So let's just double check our figures. It looks like we've got a mistake somewhere. Right. Let's go through it. 420 times by 2/7. I'm fairly confident that one was right. 120. So we check that one. 420 times by 0.35. Okay. Check that as well. Check that one as well. Okay, here we go. Not sure what I did there. 153. Should have been able to spot that. Right, so 153 divided by 9 is going to be equal to 17. So each part is worth 17. We only have to work out the lemon cakes. So 17 times by 4 is going to be equal to 68. Question 30. 4 bias coins A, B, C, and D are thrown. Which coin is least likely to land on heads? So I think it is going to be coin B. No. So this one has the smallest probability. Which coin is most likely to land on heads? So this would be 0.3 reoccurring, which is actually bigger than 0.33. So that would be coin C. Got another part to that question. Julian says the probability that coin C will land on heads is the same as the probability that coin C will land on heads is the same as the probability that C will land on tails. Is she correct to give reasons for your answer? No. No. Probability of C landing on heads, so C heads, is equal to 1/3. The probability of C landing on tails would be 2/3. So no. So not equal. Part C, coin B is going to be thrown 4,000 times, so I'm automatically assuming I'm going to need 4,000. Work out an estimate for the number of times coin B will land on tails. So times by the probability of coin B. Coin B was 0.033. Just a 0 out there. So 4,000 times by 0.033, we're looking at 132. Work out, giving your answer in standard form. So on a calculator paper, we use the standard form button on our calculator. So we type it in as 3.42 times by 10 to the minus 7. I always use the minus button rather than the subtract button. And we want to divide that by 7.5 times by 10 to the minus 6. Right, I expect that we will get a number, as it's a 2-mark question, I think our answer will not be in standard form, so we'll need to convert it. Right, so calc equals 0.0456, that's where the first mark comes from, and then converting that, so that would be 4.56, so we move the decimal from there to there, we've moved it 2 spaces, so it's times 10 to the minus 2. Okay, question 32. The graph can be used to change US dollars to British pounds. Okay, Rosie brought a ring in the US. She paid $345 for it. Work out in pounds the amount Rosie paid for the ring. Okay, so our issue here is that we haven't got 335 on this axis. What we could do is we've got a few options really. And your choice is completely up to you. So we want, realistically, we want a multiple of that. So I'm thinking I could use 34.5. So I could say 34.5 would just be about here. And yeah, I'm going to use that. So if we're going up in twos, 34.5 is going to be just above there. 34.5, just above there. Which, sorry, I should really draw that as a line. So we're looking at just above there. Bring it down and read it off. So this one is going up in 1, so just under 37. So we'll go $34.5 is equal to 20. Are we going to go 27, 26? Yeah, we'll go 27 pounds. So $345 is 10 times as much. My writing's going very messy. Is 270 times by 10. So I'm going 270. Right, let me just check the mark scheme. Right, the mark scheme says anything acceptable between 258 and 275. So we've got quite a range there. Right, question 33. The diagram says 2 shapes drawn on a centimetre grid. Find the area of shape P. So the area of shape P is a triangle. So the formula for the area of a triangle is a half base times height. So the base is going to be 4. The height is going to be 2, 4, 6. So that's going to be 12. And unit is missing, so centimetres squared. Write down the mathematical shape of quadrilateral Q, so that's going to be a kite. And 34, the incomplete table gives some information about the lengths of planks of wood in Ben's workshop. The total length of all these planks is 92 metres. Work out the number of planks that are lengthed 2 metres in Ben's workshop. Right, so we need to work out the total that we know so far and add them up. So to do that, we do 3 times by 5 plus 2.5 times by 8 plus 14 times by, I should type that in better, 1.5 times by 14 plus 10. So we've got a total of 66 covered so far. So if we do 92 minus 66, we get the length of 2 meter planks. So 92 minus my last answer gives me 26. So 26 meters is the total length of the 2 meter lengths. So if we divide that by 2, we get 13. So there are 13 2 meter planks. Question 35, write this number in standard form. So place a decimal point to make it a number between 1 and 10, so 5.62, and then we've moved it in effect 1, 2, 3 places back, so, or you can count the number of zeros to the minus 3. Right, it's an ordinary number, so we want to move this decimal point 3 places back, so that would be 1,452. Okay, 36. Nimra buys 2 kilogram box of sweets for £17.60. She puts the sweets into bags and sells each bag containing bags to sell. Each bag contains 150 grams of sweets. Nimra fills as many bags as possible. She will sell each bag for the same price. She wants to make 25% profit, assuming she sells all the bags. What is the lowest price that she should sell the bags for? Okay, so first of all, we're going to work out how many bags she should sell. So first of all, 3 kilograms is equal to 3,000 grams. So if we do 3,000 divided by 150, so 3,000 divided by 150, so she's going to sell 20 bags. So we want, next thing I want to do is she wants to make at least 35% profit. So if we assume that she does make 35% profit, we would do £17.60 times by 1.35. So this is going to be how much she wants to make. So 17.6 times by 1.35. So she wants to make £23.76. So the price that she needs to sell each bag for is going to be 20 times X. We want that to be greater than or equal to, let's say, at least. Wants to make a profit of at least. So 20x needs to be greater than or equal to £23.76. So x has got to be greater than or equal to this divided by 20. Okay, so £1.89. It needs to be bigger than this value, so the nearest integer bigger than this value is going to be, she needs to sell x for 1.19 at least to make 35. What's the lowest price she should charge? £1.19 per bag. Question 37. Natalie makes potato cakes in a restaurant. She mixes potato, cheese and onion so that weight of potato, weight of cheese, weight of onions is 9 to 2 to 1. Natalie needs to make 600 grams of potato cakes. Cheese costs £2.35 for 175 grams. Work out the total cost of cheese that she needs to make 600 grams. Okay, we've got a slight dilemma here, but I'll come back to that in a moment. So let's start with the ratio potato to cheese to onions. 9 to 2 to 1. She needs to make 600 grams of this, so we need to, each part is going to be 6,000 divided by 12. So I think that's 500. So each part is going to be worth 500 grams, which means if we just look at cheese, she needs 1,000 grams of cheese, because we would need to times each of these by 500. Right, the slight dilemma here is, we assume, I know the answer to this, but let's just discuss it slightly. Cheese costs We're going to assume that she can buy any weight of cheese and they don't have to be blocks of 175. So the sum that we need to do then is going to be 1000 divided by 175 times by £2.25. So we've got 1000 divided by 175. So that's how many blocks of that she would need. But we've got decimal. But we're going to assume that she can buy it in any weight. So she needs, the cost is going to be 12.8571 ... So it's going to cost her £12.86. And yeah, I've just read through the mark scheme because I said that there was a slight dilemma here, and the mark scheme actually covered it, which I wasn't aware of. So they've said 1000 divided by 175 is equal to, so this is the answer that I've given there is absolutely fine. It's just if you do it a slightly different way. So that's saying 5.71. So if we're assuming that 5.71 so she would need 6 blocks, which was what I was discussing as a slight issue with the question, but the mark scheme has covered it. So if we times that by 2.25, another acceptable, and I've messed up somewhere, there we go, 6 times by 2.25. So another acceptable answer was 13.5. So it's actually covered it as a kind of an extenuating situation within the mark scheme. So that would be acceptable as well. Question 38. Harley's house has a value of 160,000. Correct 2 significant figures. Write down the least possible value of her house. So it's been rounded to 16,000. 160,000, as opposed to 150,000 or 170,000. So halfway between those two numbers and halfway between those two numbers, the least possible value halfway between these two numbers, so 155,000, and the greatest possible value, 165,000. Now I know technically we would round 165,000 up, so you could get away with 164,999.9999999, but we tend to say in terms of bounds 165,000. Okay, the value of Rita's house decreases by 5%. Her house then has a value of 210,000. Work out the value of her house beforehand. So if the price has increased by 5%, it means that the original price has been times by 1.05. So the original price must have been 210,000 divided by that multiplier. Which I think is going to be 200,000, but we'll have a look. 210,000 divided by 1.05. Yeah, 200,000. Right, 39. The first 4 terms of a Fibonacci sequence are A, 2A, 3A, 5A. The sum of the first 5 terms of this sequence is 228. Work out the value of A. So we've got the first 4 terms here. The next term, so Fibonacci sequences are found by adding together the previous 2. So if you, so A plus 2A gives you 3A, 2A plus 3A gives you 5A, 3A plus 5A gives you 8A. So that's our first step. Now that we've got all 5 terms, we can add them together. So in effect, 1 plus 2 plus 3 plus 5 plus 8. So we've got 37A, and that's equal to 228. So A is going to be equal to 228 divided by 37. So 228 divided by that answer. That doesn't look like a nice number. So let's just double check that I haven't made a mistake. There we go, I have made a mistake. And it should have spotted it. 19A, not 37, always good to double check. So 228 divided by that answer, 12. So the first term, or A, would be 12. Question 14. Here is a diagram showing a triangle ABC and triangle ADE. Describe fully the single transformation that maps ABC onto ADE. Well, straight away, the type of transformation is an enlargement. So this should be 3 marks. Let's just have a look. 2 marks. Okay, so it's an enlargement. Scale factor. So it's normally 3 marks for 3 parts, particularly as it says type of transformation, enlargement, scale factor, and that's how many times bigger it is. So it's, if that length is 1 and that length is 4, it's a scale factor 4. And then normally need to give, for the 3rd mark, the point of enlargement. So it's been enlarged from, and we can tell that by the invariant point, it's been enlarged from the point 1, 1. Okay, and I've just had a quick look at the mark scheme, and it says 2 marks for all 3 points and 1 mark for 2 of the 3 points. So there are still 3 points mentioned on the mark scheme that you need for the full marks. Question 41, right, 37 centimeters cubed in millimeters cubed. Right, so I'm going to start like this. 1 centimeter cubed is going to actually be equal to 10 times 10 times 10 millimeters cubed. Because if we imagine 1 centimeter cubed is 1 by 1 by 1, and 1 centimeter is equal to 10 millimeters. So the volume becomes that. So 1 centimeter cubed is going to be equal to 1000 millimeters cubed. So 37 centimeters cubed is going to be equal to 37,000 millimeters cubed. Question 42. Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for his total drive from Liverpool to Sheffield. We'll call this part 1, we'll call this part 2, and we'll call this total. So part 1, part 2, and total. So we've got speed, distance, and time. For any compound measure question, I follow a similar process to this. So part 1 of his journey. 56 kilometers, so distance 56 kilometers. Part 2 is 61 kilometers. And average speed from Liverpool to Manchester, that's part 1, was, and I've got my total in the wrong place there, that's my total. So 70 was my speed, and the time Ollie took to drive from Manchester to Sheffield, that's part 2, is 75 minutes, which is 1 1/4 hours. So 1 hour and 15 is 1 1/4 hours. So that's kilometers per hour. And we want to work out the average speed. So we want the average speed, we want this value here. Right, to do that, I want the time that this journey takes. So if I do speed is equal to distance divided by time, we often use just a formula triangle for this. So if I rearrange that to find time, time is going to be equal to distance divided by speed. So the distance divided by the speed, so 56 divided by 70 is going to give me 0.8 of an hour. So my total time for the journey is going to be 2.05 hours. I've just added those two together. My total distance for the journey is going to be 56 plus 61, so that's going to be 117 kilometers. So my total speed, my average speed for the whole journey is going to be distance divided by time, so 117 divided by 2.05. So my average speed for the journey is going to be 57.07317. So we're going 57.1 kilometers per hour. Right, Annie drove from Barnsley to York. Average speed was 680. Average speed for the second part was 60. Yanni says that the average speed from Barnsley to York can be found by working out the mean of 80 and 60. If Jane is correct, what does this tell you about the two parts of the journey? Well, it would need to be the average speed for the first one. So, right, the average speed for the first one plus the average speed for the second one is equal to the mean of the two. So, the first thing it could mean is that the time taken is the same. Time taken is the same for both parts. That's the first thing it could mean. And that will be absolutely fine for your 1 mark. There is a second answer, very rarely done though. So in theory, and it kind of builds on the fact that so 60 over 80 is the same as 3 over 4. So that would mean that it would also be true that Leeds to York would be 3/4 of the second distance. So Leeds to York is 3/4 of Leeds Barnsley to York. That would hold true as well, Barnsley to York. But that one's much less common. That was the main one, the normal one. And that brings us to the end of the paper. Before I go, so again, this paper was created using first class maths key topic revision list. I then looked at this huge document called the Edexcel Foundation and Advanced Skills Mapping document, which has a list of every single question on all of the papers. I then matched those topics to questions that matched the key skills list. I then compiled my paper and arranged it by difficulty. And that's actually the data. That was an old version of the document. And then I arranged it by mean difficulty. But what it does actually on this sheet, which is really quite useful, it gives you the average score of candidates who achieved which grade. So the average score on that paper for students that would have achieved 5, 4, 3, 2, 1, which gives you an indication of the grades needed on that paper and how difficulty it was. So the mean difficulty of that was 55% overall. And the mean score on that paper was 57. So that indicates that roughly you needed 22 marks for a grade 1, 36 for a 2, 49 for a 4, 61 marks on that. So it was a very challenging paper for a 4 and 71 for a 5, just to give you some indication. And again, thank you very much for your time in listening to the video. Once again, that was a very likely topics based on paper 1 analysis. There is a good chance topics based on paper 1 analysis as well that I would encourage you to have a look at. Please do add any questions, comments or feedbacks into the chat for this video and I'll get back to you fairly quickly. I'm fairly good with that. I hope you find it useful. Good luck with the rest of your revision. In the chapter index, I'll also put the topics for this paper. So if there's a particular question that you struggled with, you can do some independent revision on that. And I hope you found this useful. If you have, please do subscribe if you like.